Hi, everyone. Today we're going to talk about this big fancy word called arithmetic tables. And sometimes we use boxes instead of tables, or sometimes we call them in and out tables. So the vocabulary we use, like I said, is called arithmetic tables, and they can be often referred to as in and out tables or function tables. And like I said, rather than tables, sometimes we use the word boxes. So what are they? They are tables or boxes set up just like this one you see here. Sometimes they're vertical up and down, and sometimes they're horizontal like this one. And what it is there is a pattern to them. There are numbers that go in, and then there are numbers that come out. But something happens to them once they go in. So I always like to tease and say, what goes in must come out, right? Just like foods we eat, they go in and they come out. Well, on these boxes or tables, there's a number that goes in almost like a robot, okay? A number goes into the robot and it kind of spits a different number out. So take a look at this first example. This first example is all about addition. There's the inside. This one happens to be vertical. The inside here, look at these numbers: 178, 775, 853, 936. They're all quite different. But then if you check out the other side, there are certain numbers missing. So 178 goes in, but there's a blank on the outside. We're not sure what number is going to come out. But if I look at 775, there is a number that comes out, and it's 804. But I don't know what happened to it. Do you notice the rule here? It says add blank. I don't know what happened to 775 to make 804 come out. We have to figure that out. 853 went in, and I'm not sure what's going to come out. 936 went in, and 965 came out. Again, just like the 775, I don't know what happened in the 936 to make a 965 come out. Now, again, this one happens to be addition. So in order to figure out what happened from the in to the out, we're going to work backwards. So what is the opposite of addition? Can you tell your teacher? The opposite of addition is... You should have screamed subtraction. So let's work backwards. Let's go from out to in. So if the opposite of addition is subtraction, let's go back up here. 775 to 804. They added something. Let's work backwards. So we should write a subtraction problem. 804 minus 775. So let's follow me over here. I already wrote it. 804 minus 775. Let me switch colors. Ready? So 4 minus 5. And I see there's more on the floor here. So I have to go next door. There's a 0. Can I borrow anything from the 0? I certainly hope you're telling me no. So I need to go next door again. I'm going to cross off the 8. The 8 becomes a 7, which makes the 0 become a group of 10. Let me switch colors again. Let's go for pink. Come on, pink. There we go. So can I do this yet? I still have more on the floor. So I go next door. Now this guy has some for me to borrow. My 10 becomes a 9. My 4 becomes a 14. Now can I begin to solve? I can. So 14 minus 5 is 9, and 9 minus 7 is 2. So 804 minus 775 gives us 29. So if I flip back here, 775 went in my little table or my robot here, and out came 804. So what ended up happening? What did they add? They added a group of 29. So I'm going to come up here, and now I know my rule is adding 29. Fantastic. So everything that goes in must add 29. So let's double check this down here. So we still have to work in reverse. So we need to take 965 and subtract just to double check that that rule works, okay? Because they may have made an accident or mistake, right? They could have had an accident. So let's just double check to make sure they didn't make a mistake or have an accident, right? So we need to make sure. So let's take 965 and subtract 936. Don't mind my beautiful writing here, correct? All right, so let's change colors. Let's go green this time. So 5 minus 6. Can I do that? No way. I have more on the floor. I got to go next door. This time I have a 6. Can I borrow from the 6? I absolutely can. My 6 becomes a 5. My 5 in the ones place becomes a 15. Fantastic. So 15 minus 6 becomes a, I hope you said 9, and 5 minus 3 is 2, and 9 minus 9 is 0, so I don't need to do anything. Did I still come up with 29? I did, which means my rule is correct in adding 29. So this is perfect. So both cases, in went a number and they added 29 and out came the correct number. So now I can go back here. So 178. What do I need to do to it? I need to add 29. So in comes 178. I need to add 29 and out will come my correct number. So let me clear my whiteboard here. And I need to go back to black and I need to write 178, and I need to add my rule. What was it? 29. So 8 plus 9, everybody, is, I hope you said 17. 7, I need to carry my 1. 7 plus 1 is 8, and 8 plus 2 is 10. I need to put my 0 and carry my 1, and 1 plus 1 is 2. So 207. So in came 178, and out comes 207. Do you see what we're doing? Let's do one more here with the rule of adding 29. So 853 goes in. Here we go. Let's clear my whiteboard. So in goes 850. That's one large 5, Miss Yerrick. 853, and I need to add 29 because that's the rule of my table, correct? So what is 9 plus 3, or 3 plus 9? It is 12. I need to put my 2, carry my 1. 5 plus 1 is 6, and 2 more is 8. And bring down my 8, 882. So 853 adding 29 gives me a total out of my machine here is 882. And we've now filled up our in and out table with the rule of adding 29. Let's try another example. In and out. My rule here is subtracting 7. Most of my table is filled in. So in goes an 8, and I have to put something in this out box. In goes 8, I have to subtract 7. So what's 8 minus 7? That's pretty simple, right? 8 minus 7 leaves me with 1. Perfect. So then here we go. A 13 goes in, and I subtract 7. I should get a 6. A 19 goes in, I subtract 7. Do I get 12? Good. So now I have to work backwards again. So a 21 came out. So I'm subtracting. What's the opposite of subtraction? It's addition, right? So I need to add 7 to get what went in. So what's 21 plus 7? What's 21 plus 7? Who can tell me? It should be 28. Good job. Do you see how we worked backwards and filled that in? That one was pretty easy. Here we go. Now we're going to multiply by 5. What goes in must be multiplied by 5. I know we don't know all of our multiplication tables quite yet, and that's okay. We can count by 5s. Are you ready? So 5 multiplied by 5. So count by 5s 5 times. 5, 10, 15, 20, 25. And I like to rhyme this one. 5 times 5 is 25. So 5 times 6. Count by 5 6 times. 5, 10, 15, 20, 25, 30. Good job. How about 7 times? 5, 10, 15, 20, 25, 30, 35. Are you seeing a pattern on my out box side? What do you think 5 times 8 is? If you said 40, you're correct. Nice job. Do you see a pattern on the inbox side? 5, 6, 7, 8. Sometimes you'll see a pattern on both sides that's pretty easy to pick up on. Sometimes there'll be a pattern that's not so easy to pick up on. Check out slide 6 here. We have to find the rule. A 2 went in and a 10 came out. Check out the whole box over here. Can you find the rule? A 2 went in and a 10 came out. A 5 went in and a 25 came out. A 1 went in and a 5 came out. An 8 went in and a 40 came out. I'll give you a hint. Do you remember that last slide I said there was a specific rhyme? If you said the rule must be times 5, you're correct. 2 times 5 or 2 5s, 5, 10. And 5 times 5 is 25. And also anything times 1 is itself. So 1 times 5 is 5. And that last slide also had 8 times 5 on it, which got us to 40. I'm going to share one last thing with you, and it's a video. Here you go.
We're in a hot air balloon going up to fly. The table shows our time and height in the sky. The 1 minute we're 3 meters off the ground. At 2 minutes we're 6 meters up, staring down. At 3 minutes we're up 9 meters high. What's the rule that shows our place in the sky? If we multiply any input by 3, we get the output. So that's the rule, you see. In goes 4, out comes 12. In goes 5, out comes 15. Swell. In goes 6, out comes 18. The rule is times 3, and the view is pristine. What's happening between the in and the out? We can all find out without any doubt. Make an educated guess and test it out. Till you find what the rule is all about. I have a fucking machine, the best you've ever seen. I put in a 9 and out came a 3. I put in 15 and out came 5. And then 27 went in and out came 9. There's only one thing I wanna know at this junction. What on earth is my machine's function? If you divide any input by 3, you get the output. So that's the rule, you see. In goes 6, out comes 2 for sure. In goes 12, and you know out will come 4. The simple output table has a rule. It's divided by 3. Man, that's pretty cool. What's happening between the in and the out? You can always find out without any doubt. You can educate us and test it out. Till you find what the rule is all about. When there are 2 sets of values and they share a mathematical relationship of functions there, and we can use our mind or mathematical tools to find and describe the relationship called a rule.